Hello guys, good morning. Welcome to another episode of Xa Talk Show. We are going to code Wolfram language, Advent of Code 2024, day 5. This is take 2. So last time, about a week or two ago, I did it, but it turns out my algorithm is incorrect. So Xa Talk Show 2024, Advent of Code 2024, day 5. Last time my algorithm for sorting is incorrect. So let's do it again. Time goes fast. Now it's 17th. Now I'm 10 problems late. But anyway, let's do it. Okay, Advent of Code day 2024, day 5. So let's start coding. Okay, so let's just begin coding. I'm using Wolfram language and Xa Wolfram mod. Okay, so what is the problem? Okay, so let's just start coding. Advent of Code day 5. We got a problem here. If you are here, say hi. Love to see your comment. Hello, Dan V. If you are watching offline, skip around and play at speed 2. Speed 1.5 or 2. Okay, and here is all the commands of my Emacs core. Okay, and this window gotta move here so that so day 5, what was the problem? Day 5 is given a list of pairs like that. Each line specify an order, so the first element comes before the second element. So a list of pairs, they specify an order. Then you got a list of lines. Each line, you want to determine if the line is already ordered according to this list, okay? According to the list of pairs. You want to know if it's already ordered. Then what you want to do if, let's see. So when they are ordered, so if the line is already ordered, then you want to take the middle number, the middle of the list, okay, and then you want to add them up, okay. So that is a problem. So let's do from scratch, okay. So last time I did the problem here. Let's see, mini problem, generate the least correct answer, part 2. Actually, that's not correct. Okay, so we gotta do this again. Okay, so let's just copy it, paste. Okay, so code logic is wrong. Okay, so anyway, so we got the input, the total input like that. Then we got then input is read string. Read string is, so this is my personal input. Okay, we don't want to use that yet. Then you got the pairs and lines. Okay, so pairs and lines. Okay, then you want to turn, you pass the text, so they become, then you assign to pairs. Pair is a list of pairs of numbers. Okay, and lines is just a list of lists. Each list is a list of numbers. Okay, so if that is correct, then you can just say, let's just make sure that that is what we got. Okay, can we run it? No. Okay, so you need to print all intermediate expressions. Yeah, it's still null. So you gotta say, so what I want to do is I want to see pairs and lines to see if we actually parse it correctly. Okay, so you got that. Tab A. Okay, so here is the result. So let's see, the pairs looks like that. Sounds good. And the lines looks like that. Sounds good. Yeah. Okay. Okay, so we got the pairs and we got the lines. Okay, these are pairs and these are lines. Then what we want to do is, you got list of pairs, so you want to determine if each line is already ordered. So you want to first turn these pairs, list of pairs, into a kind of ordering specification, so you can right away know which number comes before which number, given any random two number. You see, this list of pairs, they kind of chain up to form an order. Okay, so you got a list of orders. So so there are many ways to do this, and what I want to do is to create. Let's hold on a second. Let's see. Okay, this is incorrect. What? What I want to do is to build a list of numbers of all elements in the pairs list. Okay, build a list of ordered sequence such that items are from all the pairs and all elements in proper order. Okay, that's what I want to do. So I call this variable order sequence. Let's stop this. Can we? Okay, 7 people watching. Okay, so what's going on? What? There is some windowing issue. Okay, so okay, so we want to build this order sequence. Okay, so how do you do that? So I worked on it a little bit last time, so I know what to do now. So yeah, so you first of all take all the numbers here, x pairs. Okay, what you want to do is you take the pairs such that you flatten it. So they became just a flat list. Okay, then you want to say delete duplicate. Is that right? Yeah. Delete duplicate. Okay, delete duplicate, and then flatten pairs. Okay, so that will get you. Let me show you in Wolfram language here. So you got the code here. So let's evaluate it. So you see 47, 53, 97, 13. So yeah, that's basically, that's the, let's check. 47, that's the numbers here, all the possible numbers. Yeah, okay. So let's say unique numbers. Okay, so that's basically the set of the universe. And then what you want to do is you want to order this list, okay, using these pairs. Okay. Yeah, how do you do that? Well, last time we did it with this thing, but the algorithm is incorrect. because oh yeah, we I remember what's going on, because we need to actually repeat it. Okay, so it's slightly complicated. So let's see what I want to do. So you go through each pair, numbers, and then you check, basically, if the two numbers are in the wrong order in your list, then you swap them. Okay, you go through this each pair. If the numbers in your list is incorrect, you swap them. Okay, after you're done, you repeat this until there's no two numbers that's in incorrect order. Okay, so let's see. Let's what? Where are we? Unique numbers. Okay. This should be called universe set. Let's say unique numbers because that's more concrete. Okay, so go through each pair. If they are in the wrong order in unique number list, swap their position. Okay, do this again until none are in wrong order. Okay, so let's do that. So go through each pair. Okay, so map is a very standard way to go through each pair. So what we want to go through is, map a function to these unique numbers. Okay, and what is a function? The function will actually we need to go through the pairs. Okay, not okay, so actually you need to map to the pairs. Okay, now you want to map a function to the pairs, of course. So what the function do? It will do something with the unique pairs. So what the function will do is let's say given one pair, let's say this function takes two numbers, okay, a and b, a and b. Suppose that's two items in a pair. That's an argument. So the function takes two arguments, a, b, b. Okay. Now, what does the function do? It okay, so basically you want to swap the items, but okay, now we run into an efficiency issue. Hello, Diego. Hey, new took our lives. Thank you, welcome. This is probably boring. That's why I stopped. Ideally, it would be nice if I quickly solve the problem in 30 minutes, so people get a nice understanding of the problem. How do you use Wolfram language to solve it? But in reality, you're often stuck in the middle for 5 minutes or 10. Yeah, so I feel bad every time that happens. But anyway, so the function takes two arguments. Okay, so that's, takes two arguments, and here's a function. And what do you want to do? You want to see if the two numbers given in the unique numbers list if they are in the right order. So yeah, how do you do that? Well, you know, what you can easily do is that you check, you know, but that's very inefficient. So for example, let's just do the simple way, okay? Member Q, member Q returns true if the item is in it. Yeah, we know it's always in it. So we want the position. So to get the position, you use first position. What you can do is use this function, first position. It will take a list, okay, and an expression. So for example, this will return the position, the index of A in the list, okay, and you do the same for BB, and all you have to do is you check, you know, check if that is less or equals to that. Yeah, but this is not efficient because you every time you do first position, you are basically searching through a list, then you search it again, and not efficient. Well, so what we can do is this. So we can do positions, okay. This will return, so position. So what you do is like this, okay. So give a list numbers and you want to know the position of both AA and BB in one shot. Yeah, so both AA and BB in one shot. So so let's magnify this so you can see. Give the list of positions at which object matching pattern appears in expression. Yes, that's what we want. What is the default level spec? Okay, we need to change this to 1. Yeah, so it doesn't search nested list. So you want, here is a pattern, and here is you just want 1, means depth 1 only. So you don't dive into sublist, because Wolfram language, the Wolfram, every Wolfram expression is nested, just like Lisp. So this position will not just search a flat list, but it will search any list down to any nested element. So by default, it's every element, you know, you can see from 0 to infinity. You don't want that because all you got is a flat list, you know, these unique numbers. Can we get the unique numbers here? Yeah, so let's copy that. Copy. And this is an example of the unique numbers, okay. So our list is flat anyway, so this last parameter shouldn't matter, but let's just put 1. Okay, so the pattern will be apparently AA or. So what is the or? BB. So I believe that's what it will do. So let's try, okay. So let's try 1, 2, 3, 4, 5. That's a list, and this is, let's say, 4 or 5, and we can run this line, you know, so that returns 4, 5. That's correct, both of them. So you see the pattern matches here. Okay, so that's a toy example, kind of the toy example there, showing how position works. Okay. so let's go back to our problem here. So you want from this and that, okay? So you given that, then you want to see they return nested list, okay? So you want to see you can flatten it, okay? So flatten of this thing. So then you got a list of two numbers. Then you want to see if they are ordered. Let's check. So order returns either 0, 1, or -1. So you can see if they are in order, it returns 1. If they are not in order, it returns -1. Otherwise, if they are equal returns 0. Okay, so that's what the order does. So for example, order 3, 3, it returns 0. See, so for example, order 3, 4, eval the current line, it returns 1. Okay, so that's another toy example. Let's put the toy examples there. Okay, so now back to our problem. We flatten this. Okay, then you just want to apply ordered to it. Apply this order function. Okay, so let's do that. We can in fact actually we want that. Okay, so that just means, okay, well, that's a shortcut for, let me explain what this does. Okay, so whenever you have some symbol ff at something, okay, this syntax is exactly the same as, it's just a shortcut. It's exactly the same as okay, it's exactly the same as that, because we can actually try it. Evaluate the line that returns true. So this is just syntactical shortcut. So you can just say ordered, then that, okay, and that will return 0 or 1 or -1. So when it's 1 or 0, that means they are already in order. So if this thing is -1, then you need to swap them. Oh God. So much tedious coding. So if it's 0, then yeah, you can do that. So for example, if statement, if the argument is 0, if it's -1, that means you need to swap it. Otherwise, do nothing. So how do you swap it? Well, to swap it, you can just say this process is enjoyable too. It's more realistic than having all perfectly planned. Yeah, thank you. Yeah. Okay, yeah, but it takes long time. Yeah. Okay, so we got hello Damsic. So okay, so let's push on. Let's stick with this algorithm. Okay, I mean, usually I find it lots of tedious coding, and I don't want to do that. But let's stick with one algorithm. That that kind of the things I learned doing live stream. Once you have an algorithm, stick with it. Don't like try to make it more efficient, because then you go into other holes. Okay, let's stick with this. So if it's -1, you want to swap the elements. How do you swap? So what is the efficient way to swap two elements? Well, you can just say, something like this, okay? Something like +1 equals to BB, right? Wait, so position plus A equals to BB, something like that, and position of the BB equals to AA. That's how you swap. Oh, actually, it's better. Let me show you a better way. Okay, that's how you swap two elements. Let's see. Yeah, position AA, position BB, and swap it. Okay, so that's how you get. Yeah, but this is not functional programming. So once you swap, you have to return that. Then in fact you have to assign this to a new, something like assign that to okay, let's think about functional way. So basically you are given a list, you find a condition to determine whether you want to swap two elements, okay, and you want to return a result of the new list, okay. So let's look at so that's our function here, okay. Basically this we don't want. So basically, if this thing, okay, is -1, then swap it, then just return that, okay. Otherwise, no means do nothing. Yeah, that will do it. Are you sure? Yes, I'm pretty sure. For example, let's try, okay. So what is our unique numbers? Let's try. Do we have it? Yeah, here. Okay, for example, let's try it. Where is it? Yeah, so let's put so here's our function. So now let's try the function on real data. Okay, so here is the real data. Well, I mean, so the AA and BB needs to be a pair. So for example, let's pick one that for example, 7553. Let's look at, we want to pick one that needs to be swapped. 53 comes before 75. Wait, 75 should come before 53. Okay, so 75 and 53 is a good pair because that needs to be swapped. Okay, copy that, go back down here. Go back down here. So this AB is actually that. Okay, I mean that. 7553, right? Yeah. Okay. Okay, so back here, and so this function, okay, so here is a function. So this function, this will work, I'm pretty sure. So yeah, but okay, so let's try it out. Unique number equals to that. Then I want to make this a pure function though. I don't want it to rely on a variable. But anyway, so this function takes two arguments, and the argument is a pair here, and then the A and BB are the inputs. Yeah, but you don't know what is the position X and Y. Okay, so you actually, there's more complicated thing you have to do. So so you need to assign variables, position A and BB. Okay, let's do it. This is the tedious things I'm trying to avoid, but now you need, let's do this first. Okay, so you need two local variables. That is a position. So module is how you do local variable. Module is like JavaScript let or Lisp's let or Haskell's let. So here's your variables, local variables, two of them. Then you just inside, then you just put this if statement inside. That's what you want to do. Okay, so the function, two local variables, and what is the value of the local variables? Well, the values are, you assign them. Okay, so yeah, so the value there. Okay, so that's how you get the two local variables, their position. Is that right? A or B? Wait. Okay, this is not good because it may return, so you don't know which order they actually came. That's a problem. Okay, another problem. Because you are using a pattern A or B, so you don't know what exactly which one it found first. Okay, let's look at position. Position, can you take a list? No. You see, the problem is, let me try to explain. The problem is when you use position, you see, let's say 4 and 5 are in different order. Okay, now if you evaluate it, the result is gonna be the same as that. Wait, yeah, you see it, because they tell you the things you want, which is 4 or 5, occurs in two positions, position 4 and position 5. But in both cases, it doesn't tell you which one is which. So that's not good. So instead we can, we want to map the position, map each number to map the position, you want to map the position to the pairs. Well, that means it's more slow, so our code is becoming bigger and bigger. I don't want that, because the whole thing can be done in a functional way, more easy. So there is that issue. So that's not good. Okay, so now let's go back here. So now what you're gonna do? Well, you can go back to the inefficient way. Yeah. Okay, let's just code that. Okay, remember, don't fuss about efficiency and stuff, just get it done. Okay, so position, let's just do this. Position AA equals to just AA. Okay, no fuss about. In fact, since now we just, you can just say first position. Okay, because we know it only occurs once. This is simpler. Okay, so first position, because we know the item only occurs once. So once you found it, stop searching. That's what this does. First position expression pattern. Okay, so expression and pattern. So this is expression and pattern, and we don't need that. Okay, it also takes the level spec. What is the default level spec? Okay, default level spec again is 0 to infinity. That means all nested. Your search go through all nesting, so we don't want all nesting. So we need to say 1. But then you need this intermediate default. Default is null. Okay, it shouldn't happen because we know the pairs, any item in the pairs always exist in these unique numbers. Okay, so what does the default return? I'm curious now. Default. Oh, by default it returns missing, no found. Okay, I don't care. But I do want the level spec. Okay. And null in Wolfram language is just like nothing. Yeah, absence of expression or result. Okay, so that is what we want. Then we don't need this anymore. That gives you the position of A, and then you just BB and that. Okay, so now the code becomes simpler. Okay, to read. And in fact, do you want flattened? So let's see. We don't want null, so let's check some examples. It returns a list. Okay, so it always returns a list. Right. So this first position always return a list. Yeah, so in fact you can first. So that makes it a number. You don't want the list. Okay, so that is done. You got the position, then this part. So then you can just say order position AA, position BB. Okay, if that is equals to -1. If so, that means you need to swap. Then what is the efficient way to swap? You see, we can do this, but however, this is not functional. Because then, well, then you just return numbers, yeah. I mean, you just return that thing. It should work though. So let's not worry about efficiency and functional style. Let's just get this to work for now. Module, so there it is. That's our function. So if we evaluate this, we should get a new list such that the 75 and 53 is swapped. Okay, you see, so we evaluate this. Do it. Invalid syntax in or before 73. Okay, we got a problem. Oh, this needs to be moved here because otherwise, yeah. Do it. Beautiful. Did you see that? It worked. One-shot coding, no nonsense. You see, here's the result. 75 and 53 has been swapped. So this is like a toy example. So we don't need the previous no more. So here is a toy example of sorting. Example of swapping a list. Swapping two items in a list according to a given pair. Okay, so that's so this block of code is just another toy example. Okay, we solved that. What's the next step? We can move on, or we can try to refine this so that it's more functional and more efficient. Let's move on. The problem with not concerning about efficiency or functional style of coding is that basically once you get the answer, you are not interested in like fixing it, change the style anymore, because you just done it, yeah. So anyway, so this works anyway, but that's not this is not efficient. Okay, so let me think about it a little bit and let's see what's the next step. This about ordering issue. Okay, so Wolfram language. Let's go to my Wolfram language tutorial. Let's go to list, because there's a lot functions that works on ordering stuff. Ordering is part of the order theory. I mean, there's a whole kind of entire branch of mathematics about ordering theory. So Wolfram language has a lot of function that deals with order. So let's see. List operations, sort, reverse order. Okay, so you got order by. So let me think. So we need. So right now we need to create this order list via a list of pairs. So now we have this function. What we need to do is we need to apply this function. Let's give this function a name. Swap two items. Okay. Equal. Okay. So this is f. F means a function. Okay, this function swap two items given a pair. So swap pair. So swap pair. Actually, better name is reorder pair. Okay, so this function will reorder a pair. And now what you want to do is you want to apply this. Okay, let's push on. So you want to apply this map reorder pair to all pairs. Okay, wait, not here. Okay, x pairs. You want to map this to all pairs. That's right. In fact, you want to use map thread instead, because if you use map, that means your function takes one argument, but your function, our function, takes two arguments, a and b. So what you can do is you just say map thread with the same function, but here you transpose the pairs. So you got, instead of a list of lists, a list of two lists, now you transpose. So it's still a list of two lists, but instead of each list being a pair, now it's a list of all the first part, then a list of all the second part. That's what the transpose pairs do. Okay, then you don't care about that. So that's what you want. Okay, so you want to do that. So we can actually do that. Okay, so map thread, and let's see what it returns. Okay, so let's combine. Okay, so let's evaluate. So make a backup, evaluate this region. Map thread. Okay, something error, least expected. Okay, something something. Oh, okay, so we don't want that there. So here is a function. Yeah, function. This is a function. Okay, then you can test the function on that thing. Then okay, so then you map this function to that. Okay, so delete that. Yeah, let's try again. This region of code. Okay, evaluate it. Map thread, some is still problem. Okay, so still some problem. Okay, let's see what is the problem. So let's just evaluate this. Okay, we got this new list. Okay, actually, let's modify this reorder pair so that instead of taking two arguments, it'll just take a single argument of the pair as a list. You see, right now it's taking two arguments. Yeah. Okay. So. Okay. Let's work on this. Okay. So let's create a new section. Let's work on this. So this will be just pair. And let's just say, well, pair. Okay, let's just say XX, and here you will be yeah, so then we want to, so then we add more variables, AA and BB, okay, two more variables, and AA and BB will be AABB equals to XX. You see, let's rename okay, so the function takes one argument, a pair. In fact, you don't need that. So it takes a pair, then then we declare some local variables. Then the first thing we do is assign the pair a name. The first element AA, the second part is BB. Okay, then you got, then you got your AA and BB. Yeah. Okay, so let's just yeah. So now we can try. For example, we apply this function to this pair. Okay, and actually we need this thing. Okay, so there. Evaluate the region. Let's see what we get. Finished. This is incorrect. What do you mean finished? Oh, wait. If, what? Oh, okay. You changed the variable. Too much changing of variables. You made a mistake. You forgot to do that. Okay, so this function, if it's in order, return that. If it's not in order, you just return that list itself. You need to do that. Okay. Yeah, okay, so you do this again. Evaluate the region. There it is. So it's 75 and 53 reversed. No, it is not. No, which is incorrect. For variety, let's try it here. 53. No, okay, so it's not right. God, what is going on? Damsk says, I can officially say that I've mastered Xafly keys now. Fantastic. Using Cormac key binding layout. Fantastic. So great because it has so many features of other packages. Yes, started adding my key binding under XAR command map. Fantastic. Thank you. That's Xafly keys. That's the efficient key binding system for Emacs. You can get it on GitHub. Okay, so back to this problem. This is wrong. 75 should come before 53. However, the result, our evaluation is this, okay, and this is just not right. God, the coding is just tedious little problems. What's going on? Did we, we just try to change something, but then you got Oh, fucked. Oh God, we just need to change. We are not done yet, and it's already 1 hour. How did these people, this advent of code, finish in 2 minutes? Okay, concentrate. Okay, so this is a pair. That's right, because you a list of 2 items is the argument. Okay, then the first thing you do is you assign them a pair, right? Did we? Yeah. So you got, you assign them to the pair. Then oh God, this variable, I tried to rename variable, I forgot something too. Again, that's my bad. Okay, so now try again, it should work. Okay, so eval the region. 75 comes first. That's right, so we got this result. Fantastic. Okay, finally our code is good. Okay, and now we can remove the previous toy code. Okay, so we can just remove. Okay, so there. Okay, so now this function will reorder a pair. Now actually we don't want, now we can, we no longer want map thread. We want to actually nest it. Reduce. Okay, so reduce in Wolfram language is called fold. Okay, let me show you. Okay, so wait, fold. What takes 2 arguments? Okay, the first part is reorder. Okay, reorder the pairs. Then you got you want to fold to this list of pairs, beginning with the first pair. Okay, so yeah, so I think that's it. That's that. So let's look up fold documentation. Yeah, okay, so you see there. In Python, in JavaScript, this is called reduce. In some languages, it's called fold. In some others, it's called reduce. So why you want fold instead of map? Because every time you swap 2 items, you want that to be the new input. Okay, so you fold it. So after this fold, you should get an ordered list. Okay, as what we want. Okay, so let's now evaluate this part, make a backup, and now evaluate this region. Okay, something wrong. Okay, non-atomic expression expected. Okay, so non-atomic expression. Okay, you got something. Let's see what the this is how you debug Wolfram language. So so it's not very intuitive, because Wolfram language works by term rewriting. So if you code Lisp, you'll understand it's like every function in Wolfram language is doing a macro, a Lisp macro. Okay, that's how Wolfram language does computation. So imagine in Lisp, Emac Lisp or Common Lisp, every single one of your function is written using Lisp macro. That is essentially the heart of Wolfram language. That's what we are doing. So unlike typical procedural languages using values, your error is gonna be quite different. So it's saying that fold normal, so it's this error is about fold, and the message is about normal. It's something about normal, the fold function normal. Okay, non-atomic expression expected. So non-atomic. So basically, it doesn't want a number or a symbol. It wants a list or something. So in this expression, fold function, that you got a non-atomic. So usually when you see some error Wolfram language, you just look at your code and re-examine your code. Then you can find what's the problem instead of like dive deep into trying to understand what the error message is saying. So anyway, so we got a list of numbers, and this fold pair takes a pair, right? The pair is undefined. That's why. Okay, you gotta define your pairs. Okay, there is our pairs. Okay, that's why, of course, it's not working. That's why, of course, non-atomic expression expected, because your pairs is not defined. So let's define the pairs here, because we are making a standalone example, you see. So here's the numbers, here's the pairs. Okay, and then this function actually requires that and that. Okay, then what you do is then you fold. There it is. Let's try again. Eval the region. Okay, still wrong. Okay, wait, is that the pairs? Yeah, that's the pairs. So why am I getting... Oh, okay. Set, shape, list, and that are not the same. Oh. So somewhere I said it incorrectly. Oh, okay. So now if you're gonna fold, yeah, this function takes one single argument. But when you use fold, it requires function that takes two arguments. That's right. Oh, okay. Oh God, what a pain. What a pain, because I was thinking, using Wolfram language, it will blast through the typical algorithms you would do in Python or C++ or Java. But now it's like 1 hour already, and we got this ugly, fairly ugly code, and still not going anywhere yet. Ah, God. So we need to modify this function again. Oh, God. So the function right now takes a pair, okay? But you want it to use fold, right? If you want to use fold, you need the function to return, to take two arguments. That's right. Okay, so, I got it. So the function, it is incorrect. It's rather a design flaw for this function only to take one pair as argument, because this function actually depends on this list unique numbers. So this function, what it should do, a proper design, is actually it should take a pair and a list. Okay, so let's say X list. So let's rename these unique numbers by X list. to avoid confusion with the the global constant. Okay, so now the function takes a pair and a list. Okay, yeah, and that should work. Yes, I think so. So save it, and actually we don't want that. So let's work on our section. So here, okay, now evaluate the region. Oh God, still wrong. What the fuck? Wait, right? Let's double check. Okay, so a pair and the list. This part. What is the problem? Normal non-atomic expression expected at position 1 in first. Oh, so you got a null. Okay, so somewhere here, this part is returning null. Why? First position of AA in X list non-atomic expression expected, so this part it returns null, so something is wrong. Did we? Let's try. Oh yeah, I think I forgot to select that. No. God. Hello, you are coding while drones of unknown origins are flying over your head. That's correct. Drones of unknown origins. Yeah, the news, the certain subset of white Americans' obsession about UFO, like so ridiculous. It's part of the American culture. I don't know since when, since at least since 1990s when I live here. But actually, it may go back to 1980s or maybe 1970s. There's certain like obsession about UFO and aliens, and I thought about why is that, but not, typically not the black people, not Asian Americans, not American Indians, not black Americans, not, but typically this white American. Okay, they are not, a subset of them, like the Alex Jones scammer and the Joe Rogan monkey. When you watch Joe Rogan, he's got UFO. Like Joe Rogan take, what a fucking idiot. So this certain subset of white Americans, they have like obsession about UFO, aliens. Oh my God, alien! I got abducted by alien. They So I thought, you think about why is that. I think the answer is basically life is too good. Life is too good. You got tired of pizza, got tired of Starbucks, you got tired of your trucks, 4-wheel drive. You need something like, you need entertainment. You got tired of movies, slash and burn, big giant screen. Yeah, but you got tired of that too. You need something novel. Aliens, UFO, oh my God, we got invaded by aliens. That is something novel. They insert a tube into your ass. That's fucking idiots. Certain subset of white Americans. Okay, so back to this code. Okay, so what is our problem? What are we doing? God, I'm getting distracted. Okay, we already coded for 1 hour. Maybe we should stop. Yeah, maybe I should stop, because let me continue a little bit. Okay, maybe finish this sub problem. So because I'm just, I think it's best just to have fun. That's, because before I try to finish it, turns out 2 hours or 3 hours. Sometimes, one time I did 5 hours and it's still not finished. But it became painful and not fun anymore. So, just do 1 hour coding. If I finish it, it's great. Try the best I can. If not, then we do it another time. So let me continue a little bit more to close up on this sub problem. Okay, I haven't even begin to make this efficient. Because that's really what I want to do. That's really my, let's say, the value. Okay, if you are watching my show, it's not about typical programming, because you can, a lot of people can do this in procedural way in Java, in JavaScript. There's tons of answers out there using Python or JavaScript or Java or C++ or Rust or Lisp, right? But if you look at their algorithm, if you look at their solution, they are pretty much all the same. Because although the programming languages are different, but if you look at the algorithm of how they do things, basically just came down to like pretty much all the same. Okay, not exactly, but pretty much all the same way. Because why is that? Because most of the they are procedural based languages. Okay, even including functional ones. But what I'm doing, in Wolfram language, it can be different, because it's a term rewriting system, and you got 7,000 built-in functions to do things. So I think, when I'm doing my stuff, the interesting part, the value, is about how do you do it in a different way, in Wolfram language or purely functional style. And right now I'm not. You see, this assignment and this you can, it's kind of functional, but it's not, let's say, it's not the idiomatic Wolfram language way. There are better ways and more efficient. And moreover, what I want to do for this ordering, I'm pretty sure, I know for sure, there's certain, we haven't even looked into. So there's a lot of functions that do sort, and also tell you the ordering of a list. I'm pretty sure there's like one single line or two that will return, given this list of items, numbers, and the list of pairs, there is a solution in one line or two, basically, and that will reorder this list. Okay, I'm pretty sure of that, and it will be very efficient. Now, in Wolfram language, sometimes the most shortest and elegant is not efficient. So efficiency and elegance of the code is kind of very separate. And I think that's true in general in any language. Efficiency and elegance of code is fairly separate issue. But in Wolfram language, I'm pretty certain, you can solve this problem in 1 or 2 lines and also being efficient. But the trick is just you have to look into that. You can't like just start code, and have a solution. If you want, the most efficient and elegant, you actually have to look into that, and I haven't done so. So, but let me think about. Yeah, so you don't have to like, have these tedious parts, assign the pairs to each element, then find the position of the first part, find the position of the second element, then try to see if they are in order. If not, swap them. If yes, this is like typical coding. But I'm thinking just one single line, single line using this kind of ordering function. So one single line will just figure it out for you. Anyway, enough rambling. But okay, so let me try 5 more minutes to finish this. Okay, so you got the numbers, you got the pairs, but why is it the complaint? So this function takes 2 arguments, a pair and a list, and it returns a new list, right? Yeah, it returns a new list. And as far as this assignment, so anyway, so it returns a new list. Okay, so let's not touch it for now. And then, but it's not working. Why is it not working? Because I don't know. So let's try this again. Run it. Okay, too many parameters. What too many parameters? Oh yeah, so you got remember it takes 2 arguments. Yeah, so the second argument is that. Okay, yeah, that's right. So let's run it again. Let's just combine them. So run it. Okay, so wrong. Okay, so we still got something wrong. In the part assignment is not a symbol. Okay, so you mean here. Did we get okay, so you need actually run it. What part assignment is not a symbol? So if they are ordered, then if this equals to -1, then print that it did print that. So 7553 is in position 75 is in position 6. Okay. Okay, so now what is this? Set, so this step is incorrect. Can you actually do that? Yeah, maybe I got. So let's try a list. Okay, so here's a list 1, 2, 3, 4, 5. Okay, then let's say position 3 and 2 equals to 2 and 3. Okay, let's evaluate that. Let's see what happens. Yeah, that is what is wrong. So what you can do is, let's see, do that 3, 2. Okay, let's not mess with this single line. Okay, so let's actually make these 2 lines. Okay, so instead 1 line, so it just say that. Okay, these 2 lines instead of that, make it simpler. Okay, so that swap, then just let's try it again. What? List what? What? I thought you can do this, right? So if you have a list 1, 2, 3, okay. So if list position 1, you can set it to B, right? Evaluate it. No. What? This is so basic. I got this wrong. It only works if that's a variable, I think. Let's try. Okay, so list x equals to 1, 2, 3, then x equals to bb, then you return xx. Okay, run that. That works. But if the xx, if you have xx as a list directly, then that won't work. Yeah, but we do have a list. What's going on? So what? Okay, so let's okay, so let's go to Wolfram language sort, and let's go to list. List operations. Okay, so I want to know about assigning elements to a list, about swapping elements. Okay, create list, get parts of list, add element, change element in a list. Okay, replace part. Yeah, I should use that. Yeah, actually, this is what I should. Yeah, okay, I should use replace part. So replace part is a better way, a functional way. Okay, so for example, replace part wait. That means replace first part by 99. Run it. That works. Okay, so these two pretty much does the same, but the first one doesn't work if if it's not a variable. This first part, the syntax and semantics is not functional. This is a procedural thing. So we want the replace part. Okay, so let's do that. So instead of doing that, you just say replace part of X list, replace position A by element BB. And can you have a, yeah, you can have a list. Okay, so we give a list. Okay, then position B by AA. Okay, that this line is better than those, but these two lines should still work. I don't know why is it not working. Because is it because the parameter cannot change? I think it can. Maybe not. Let's do another mini code. Let's just for fun to find out. Okay, so now you have a function. Let's say input is x. Let's say x equals to 3, and evaluate this function at 4. Okay, now if you are allowed to change the argument, then this will return 3, because assignment returns 3. If you are not allowed to change the argument, this will return error, just like the error we got. Okay, run it. Yeah, error. So you cannot assign, when you have a function like that, you cannot assign a value to the function's parameter name. Okay, that's Wolfram language. I forgot about that. So that is why this assignment, this returns an error. It returns an error, something like set row cannot assign to a row object. Okay, but now we fixed it. Close that, don't do that, and remove this debug information. So that's what we want, and it's also cleaner. You don't need this, you don't do assign and the return value. You just, this is a functional way. Okay, so that's good. So now can we run the whole thing, this block? Yes, we can. Run it. Fantastic. Now can we run, now let's cut this. Okay, now this is some explanation stuff. Let's put it at top. Okay, that's another interesting thing. Okay, but now let's go back to our code, the fold. Okay, run it. Okay, new error. God, Jesus. No, why is it no? Oh, that's why. What? If it's not found, first position, why is it not found? Because you see this list of numbers, by design, each element in this pair is always there. So why is that it says this returns null? What? So let's again debug. Okay, debug. Run it. A and B are okay. Each time you get a pair, right? So what is the problem? A and B first normal. Okay, it's 47 and 53. 47 is there, 53. Okay, let's print A and B are that, and this is okay. Run it. Go to the top. A and B is that. List is that 75, 53. 75. Wait, what? Let's not run that. Okay. Okay, but anyway, oh, here is what's wrong. List is 97, 13. Oh, wait. What? Let's not fall. Let's do this. Run it. That works. What if you try a different pair? Okay, this is getting too long. 97 and 13. 97 and 13. 97 and 13. So they should not change. 47 and 53. 47, 53 not change. Okay, so let's use that. 47, 53 no change. That's correct. What about what about next pair? 97, 61. Copy. OBS Studio problem. God. So 9761, 9761 also no change. Okay, and but so when you run the function one time it works, but when you fold, somehow it's not working. Okay, A and B are that. This is 97, so this list is wrong. So why is this list 97 fold? Did we list is 97 and 13. So the list is wrong. This becomes one single number. Where argument order is incorrect. To fold. Wait. That's right. Argument order is incorrect. So I should have used fold left. No, I should use fold right. Yeah. Stupid. So let's change our argument order. Okay. So the function is simple error. Okay. The here list and the pair, right? Yeah, that's right. If you change it, let's see. Oh, wait. Yeah, we miss. Yeah, the problem is that we are using this fold incorrectly. Another very basic error. Okay, before we do that, let's put this back. Okay, we are using this fold incorrectly. So let's think again. The function takes pair and the list. Okay, so the problem is something like this. Okay, so this is all correct, and here you need add a new thing. Okay, so you need yeah. There. Okay, I think that's it. Okay, so wait. List. Okay, so actually, so list should go in front, then a pair goes in second. Okay, So all these are incorrect order. That is better. Okay, and here is just that this whole this, okay, and that. Right. Beautiful. This so we spend an hour fixing like trivial problems, syntax error, the wrong arguments fulfilled and stuff like that. Okay, but here is the result for that. Okay, so according to, so we kind of finished this little problem. We have this independent standalone block of code. So we given this list of numbers, then this pairs, then with this will reorder them, and to create a complete list of ordered sequence would be like that. Okay, so let me show you. So that will return that. Okay, so that is how we create a like complete list. This in contrast to the original 4753. Okay, that's it for today. Thank you guys for watching. I guess one people or two. Bye guys. So today we didn't make much progress to Advent of Code 2024 day 5, but we just made partial progress on a sub problem. Yeah, okay, but it's still good. So still good. Let's put the code back. Syntax correct, show in browser. That's what we have. Okay, bye guys. Okay, we're shutting down in 1 minute. That's 100 minutes. Functional programming. Bye. It's interesting about functional programming because I love functional programming, but sometimes you wonder what good does it do when you use functional programming, Wolfram language and all these advanced exotic stuff. What does it do for you when you can actually code this in the most simple, basic way using Python? When you use Python, this would be, you would have to type much more, but you would have finished the problem earlier. Is that true? I don't think that's true actually in general. But however, when you use procedural programming, you basically just do it in one way. You don't think about so many different ways. So anyway, bye guys.